Hello, everyone. So I took a day off and apparently I missed one of the biggest jobs in LLM space. So for those who didn't know, Meta or Facebook just dropped Llama 3, which they call the most capable openly available LLM to date. And beside the benchmark stuff, basically to say in the two sizes or the two flavors that Meta dropped the model, the 8 billion or 70 billion parameters, it's basically better than the competition. Let's put it that way. What got my attention is they used a system level approach to basically safeguard the model to not being used in malicious manners. So they are using a separate fine-tuned model that control the prompt and the output, basically. So I was wondering maybe companies can fine-tune their own safeguard model in order to better control how the model is being used in their own companies. As a follow-up to my Gen Edge AI series, so what I wanted to start by deploying Llama 3 on Ollama. Ollama is one of the best tools currently to run AI models, LLM models locally. So let's get started. So if I head to Namla dashboard, click on new application, let's call it Llama 3, tenant 1, project Metropolis, and upload the YAML manifest. So a quick walkthrough in this YAML manifest. So it's basically Kubernetes manifest, nothing out of the ordinary in this case. So it's an Ollama deployment. Is the container that has the Ollama runtime. So yeah, I'm using the container from by Jetson from Nvidia. The container is exposed on the port 1100 434, and I'm using a web UI called Open Web UI that we will use in order to chat with the model, and I'm exposing the Ollama using a cluster IP that points on the container port that the Ollama container is using. I'm also exposing the web UI using a node port that maps the port 8080 on the container to node port 3000 on the host that will be running this container. Now, if we want to schedule, so I have an Advantech make that I like to use in order to run my AI models. And for those who didn't know, the MEC 733 AO is running and has an Nvidia Jetson AGX Orin, and have a couple of interesting IOs. And I patched it to the developer preview of Jetpack 6, basically. So we are running cutting-edge hardware and cutting-edge software to run one of the latest LLMs. Basically. So now we just click deploy and wait for the application to deploy. So now that I think the application has been deployed, so let's go and check on it. As I mentioned, so we're running the Open Web UI and also the Ollama runtime. So what I'm going to do is to manually download the Llama 3 model, but we can also work around that and automatize that once the container is deployed using stuff like init containers, basically, and have local storage, so that when we redeploy the container or restart the container, we don't have to redeploy it again. But I wanted to show you how we can achieve that using Namla. So we can go directly into the container, Ollama containers. In order to download the Llama 3 model, we will default it 8 billion model because it doesn't, the Nvidia board cannot handle the 17 billion. The idea is to run smaller models on edge location in order to see how we can leverage this technology to achieve and to serve applications at the edge. So to download the model, basically ollama run and Llama3, and ollama will start downloading the model. Model is 4 gigs in size. So what I like to do is basically go into the edge device and inspect the networking. So while we are downloading 4 gigs of the model, we can go and check on the device, and here we see that we are receiving we are downloading at 37 megabytes per second, and we can wait until we will wait until the model is fully downloads. Yeah, we are at 54%. So now once the model has been downloaded, we either can chat directly into the terminal with the model, but what I like to do is use web UI. So I will show you after the model has been downloaded how we can leverage both chat through the terminal and also chat through a web UI to simulate the ChatGPT kind of approach. Now that the model has been downloaded, then we can see that we picked through the downloading phase, and now we are back to normal basically, and we picked at 38 megabytes per second. Who are you? Sorry for my broken English. And now, as you can see, the thing is that the Llama3 is quite fast. It is very, very fast. And so yeah, now that we tested the chatting with Llama3 directly into the terminal, what I like to do is maybe use a more user-friendly approach, and especially if you're using deploying LLMs on edge locations, you would like that your employees or the people who would be using those LLMs not to interact with them through a terminal, but basically use a more familiar approach through a web UI. So as I showed you before, we deployed an open web UI that will call leverage ollama through the cluster IP, that the cluster IP service that is exposing the ollama default API port, which is the 1100 and 434. And so yeah, I exposed the web UI through node port, and this node port is just a mapping of 13,000 to the 8080 port inside the container. So now we go to the web UI and select the model. This web UI is basically talking to our ollama container or pod, as we call them in Kubernetes. So if we ask the same question, who are you, to the llama, we can see that the language is we start streaming the tokens basically from the large language model, and the Llama3 basically identify itself as a large language model by the research team at Meta. What I like to do is basically maybe use it as a copilot for Kubernetes, that for people that use Kubernetes. So I can ask it, write Kubernetes manifest for an Nginx deployment basically, and let's wait and see how it can perform. So it's quite straightforward. We can see the approach, some similarities between the Llama3 and ChatGPT-4. It gives you the manifest, then tries to explain the different steps that it took and in order to generate this manifest. So what I like to challenge it is maybe ask it to expose deployment using node port 30,000, and let's see if it can manage that. So now it finishes. It gives you the way to apply basically the Nginx manifest. Ask it again how to expose this deployment using the node port, and let's wait and see how well does it perform. So now it's creating a service. Everything is good. I didn't tell it to use port 80 as a container port, but I think it used its training data. Basically, almost all Nginx containers are exposed at port 80, and now it attaches the 13,000 ports. It specifies to Kubernetes that it needs to map the 80 ports to the 30,000 ports, and so yeah, here I think it messed things up because I asked for node port, so the type should be node port. Something that I wanted to show also is because it is running on edge hardware, we like to see how it is using the hardware basically. So if we go to the device that is running Llama3 and go to monitoring, let me zoom a little bit. I'm using a very small screen here. So we see that the CPU is quite, the CPU usage is quite low, just because we asked it to use the GPU rather. So if you go and watch for the GPU, and we can see that it uses the GPU when it starts doing the inference, and basically it is using almost 5 gigs of GPU memory when it is doing its stuff. So yeah, very interesting, quite exciting times, especially for edge computing space. Demo tutorial, I showed you how we deploy Llama3 by Meta using Ollama and OpenWeb UI directly into a single edge device. The device that I used in my demo is an Advantech 733 IO with an Nvidia Jetson GXR board in it. The inference time, the accuracy of the responses were amazing. So I'm excited to see what we can achieve with this new large language model, and very big win for Facebook launching this as an open source model. So yeah, take care.